Hello and welcome back. So, in previous few lectures, we have seen about the log transformations and when we use the log transformations. And in this video, we are going to see a Python sample code to perform the log transformation. We will understand with the help of that sample code that how we are applying and why we are applying the log transformation. So, I have written the code already, and let me uh, put it one by one to understand what actually we are doing. So first of all, this is my Jupyter notebook. So I hope I have already told you and you also know that how to use it. I will provide this piece of code under the comment section and I will just pin it. Okay. So I'm importing the NumPy library and the matplotlib library to plot the graph. So this library is used to plot the graph, and this library is all about the performing the numerical operations on the data, this NumPy library. So let me run it. So it's successfully executed. So it means that NumPy library and this library, matplotlib, both are available and are successfully downloaded on my system. And then let's generate some execute data. Okay, so let me control C and control V. Okay. Okay, so here we are going to generate some kind of data, skewed data. The data sample size is 1000, right? And if you want to understand that how it generates the data, this function, exponential function, then today the era is of Gemini, right? The era of LLMs, right? The AI. So you can simply go to the uh, any of the AI like Meta or maybe Gemini you can use simply. So you can simply type this, Control C, Control V here, and just put it here and just write like, can you explain what the above function call is doing? Not going, it's doing. Need to know about the function exponential as well, right? I can explain this function, but the thing is that when we have these kind of facilities available these days, like this is the era of AI, so why not to use it? Okay, so you can see it will simply explain you that how it has generated. So I hope you will be able to do this exercise yourself to understand that how it is generating the skewed data set. But how the skewed data looks like. So let me just plot it as a graph. So I'm just going to plot the histogram, right? So let me just put in here, let me run it. And now plot the histogram of the original data. Okay. So this hist function, what does it do? You can simply, go to any of the AI and ask it like, explain me in detail. What does this function do and what this function is doing here in this example, right? What it will be doing, right? So all that you can ask to Gemini or any AI for that matter. And we have set the x and y labels, value and frequency. There are two x's for any graph, and we have uh, decided those graphs. And I have given the title for the graph, histogram of original data, right? So this is the original data, and we have generated this data, and a skewed data because exponential function we have used, and the scale is of 100. So you can understand that what and how it is generating based on the scale. So let me run this section now, and let me show you that how the original data that I have generated here in this second block, how it looks like. So let me run it. So here you can see it's histogram of the original data. So you can see that it's a skewed data, right? With a long tail on the right hand side. It has a very long tail on the right hand side. This is very much a skewed data. So this data point, like if we compare this data and this data point, where the where the bar chart or the bar is very high and where the bar is very low. So if we see only this data, then in this case, what will happen? Our machine will think that this data, which is really small, is not that important. But we know, understanding our context of the scenario, we know that this data is equally important as this, right? But my machine should also understand this. So how I will make it understand like that? So in that case, I have to use some kind of transformation to use a certain scale so that based on that scale, I can distribute the data with respect to all these data points in such a way that I can maintain some kind of uniformity across the data, right? So to do this, we use the log transformation. So that is why we have understood the basic theory of the log transformation in the previous videos. Okay, so now I'm going to apply the log transformation. So you don't have to do anything. Just you need to call the np.log on the data that you have generated. So let's see. So I'm going to do this like here, and I need to run it, and it has been applied. Now let me, after applying the data, now I have applied the log transformation, and now as a feature engineer, or you can say data scientist, or you can say a machine learning engineer, I want to see that after applying the log transformation, how my data is looking like. So here you can see the scale is like up to 200 and 200, 50, 100, 150, 200. On this scale, we have generated the data. But after log transformation, this scale is going to be smaller, right? Because we will get uniformity across the data and they will all be scaled around, same log transformational value. Natural log, basically. That will be a natural log that we will be applying here. So let me show you after the transformation how it looks like. So let's put it here and let me run it again. So once you run it, you will be able to see that you can see the scale was like up to 700. But here the scale is from 0 to 6. In fact, it's minus 1, 0. I mean, some values are in the negative itself, right? And on the y-axis, where the value was around 200, it came across 80, right? So we are able to, scale our data, or you can say transform our data using the log scale, right? To an extent where all the data points are very much closer to each other so that our machine learning model will understand that all the data is really important, right? In some cases, the data may not be important, the smaller values may not be important. There, you may not need to use the log transformation. But in cases where the log, where the bigger value and the smaller values both are important for the data analysis or for the machine learning model to understand and to consider all the values, data values, then in that case, this kind of log transformation is very much needed. Okay, so let's see how it has worked here. So let me show you that what we have done. We have first generated the skewed data, where we have generated the random sample of 1,000 data points from an exponential distribution, which is a common example of a skewed distribution, which you are able to see in this, you know, uh, blue graph, right? And then we have plotted the original data in the blue graph and then applied the log transformation, and then we have plotted the transform data. And what you need to understand as a key point, so skewed data. So why the skewed data we need to consider, why we need to understand about the skewed data and its management, right? The reason is that many real world data sets exhibit skewed distribution, where a few large values dominate the data. We have already understood this in the previous videos, but yeah, as a summary, we are going through this. So then the log transformation, by applying the logarithms, we compress the range of large values, making them more manageable. Then comes the normalization. What is the normalization? The log transformation can help normalize the data, making it more suitable for certain machine learning algorithms, right? Because machine learning algorithms, they are really, whatever we are using, they are really, really sensitive to the outliers and to those values which are really smaller compared to the other values, are really bigger compared to the other values. If some value is really big compared to other values, it may be considering it as an outlier, an exception case that somehow it has happened. For example, if we are studying the about the diabetes, then there are many people who are between the range of age from 40 years to 65 years, or maybe 65 60 years to 80 years. These guys are more prone to get diabetes, but in some cases even this 2 to 3 year old boy or girl or any child for that matter can get the diabetes. But this case is really a rare one, right? So if something is really a rare one, then in those scenarios we can remove that case. But there could be some cases where the smaller values are also really important for our machine learning model to consider. So for those cases, we are using the log transformation. I hope you must have understood the log transformation, why we do it, why we perform the log transformation. So I hope you might have found this video really useful. I will provide the piece of code and I will just pin it in the comment section. So you can just copy paste it and just run it on your Jupyter Lab or Jupyter Notebook. So we'll meet in the next video with the new topic, which is standardization, and we will understand what is standardization, and then we'll see the examples as well, just like we have seen for the log transformations. So till then, have a nice day and bye bye.